going to be having a whole number, but we're just going to see how we can solve this without a diagram now, okay? This should be very, very simple because we're doing the same thing. We're kind of just taking out this part of drawing it out because we have this understanding that multiplication is just repeated addition, okay? So I'm just going to show you this first, and then we're going to all practice this together, okay? So let's say I have a fraction like 2/3. Actually, let's do 2/6. Okay, and it wants me to multiply this by 2 wholes. Okay, I'm going to take our memory back to when we first started fractions, and when we have a fraction that represents 1 whole, right, it could look something like this, right? Maybe 1/1 or 2/2, even 3/3. Oh, sorry, not over 4, 3/3. These would all equal 1 whole, right? If I were to make these into, or draw these out and see how many wholes it would make 1 whole, right? Here's my 1. It's broken up into 1 part. One of them is shaded. The whole thing is shaded. Or over here, if I had my whole and it was broken up into 2 parts and 2 of them were shaded, is the whole thing shaded? Yeah. And over here, if I had this and it was broken up into 3 parts and 3 of them are shaded, is the whole thing shaded? Yes, the whole entire thing is shaded, but now we aren't talking about 1 whole, we're talking about 2 wholes, right? It wants me to multiply it by 2 wholes. So who can raise their hand? Actually, just think for a second. How would we draw, or how would we write 2 wholes as a fraction? How would we write 2 wholes as a fraction? And thumbs up if you think you have an answer of how I would write 2 wholes as a fraction. Or you can just like raise your hand. Who thinks they have a way? How would we write 2 wholes as a fraction? Joelle, how would we write 2 wholes as a fraction?
You could draw, you can put 2 circles.
Okay, 2 circles.
And then you can fill them both.
Fill them both in, yeah. That's a great way to show it, but how would I now write this as a fraction?
You can put 1 whole. Yeah, that's 1 whole, and then they're both 1 whole, so you can.
They're both 1 wholes, right? How many parts are our wholes being broken up into, Joelle?
None.
Technically, it's just 1 whole part, right? It's not broken up as any parts at all. So it's just 1 whole part. But how many do I have shaded of these 1 wholes?
Do I answer?
Yeah, go for it.
Okay. None.
Well, how many do I have shaded? How many circles do I have shaded?
2.
2. I have 2 whole circles shaded, right? This is an improper fraction right here. If I were to draw this out, it would look something like this, and I could change this into a whole number that would be 2. Do you agree?
Yeah.
Yeah, because 1 goes into 2 times. Okay, let's show this in a different way because I think this might still be kind of a confusing idea for us. I'm going to give you a whole number, okay? And I want you to see, how would I write this whole number as a fraction? Okay, how could I write 4 as a fraction? Michael, how would I write 4 as a fraction?
Well, it would be 4/1.
Great job, 4/1. If I were to draw this out, kiddos, here's a whole. My denominator tells me how many parts it's broken up into. Only 1 part, so I'm not breaking this up anymore. I would shade the whole thing. Here's 1 1. Is that enough to make 4 ones, Michael?
No.
No, so I have to make another hole. It's also only going to be broken up into 1 part, so this is being shaded in. There's 2 holes. Is that enough to make 4 ones, Michael?
No.
No, do I have to keep going?
Yeah.
Okay, so here's going to be another hole that is broken up into 1 part, and I'm going to shade the whole thing in. That's 3 1/8. Is that enough, Michael?
No.
I'm going to probably need 1 more, right?
Yeah.
So here is 4 1/8. It's kind of hard for us to think about, or 4 holes. This one right here represents the whole thing and it's not being broken up into any pieces. Does that make a little bit more sense? Okay, you'll start to notice this pattern. Let's see. How could we write 6 as a fraction? How would you write 6 as a fraction? And thumbs up if you have an idea. Nuria, how would I write 6 as a fraction?
You will draw 6 holes.
I could draw 6 holes. 1, 2, 3, 4, 5, and up here is 6.
And then you shade them in.
Shade them all in. So how would I write this as a fraction? What's my numerator?
Your numerator 6.
6. And what is my denominator? 1, right? Because how many parts is my whole being broken up into, Nuria? 1 part, right? This 1 part isn't being broken up into 2 parts. It isn't being broken up into 3 parts. It's only the 1 part. So that's what our denominator is, okay? What I want you guys to realize is any number at all, let's say we have 24. If I want to show 24 as a fraction, I can just show 24 as my numerator and 1 as my denominator. If 1 is your denominator, this top number is your numerator, is how many holes you have. Okay? So let's try this again. How would you write 7 as a fraction? Thumbs up if you got it. Casey, how would you write 7 as a fraction?
7/1.
Good job. 7/1. How would we write 9 as a fraction? Josie.
9/1.
Great job. How would we write 563 as a fraction? Bella.
563/1.
Good job. Over 1. Okay, let's try one more. How would we write 3 as a fraction? How would we write 3 holes as a fraction? Jalal.
You could do 3/1.
Looking at what our original problem was, I believe we had 2, 6, and we were multiplying this by 2. Okay, someone raise your hand and tell me, how could I rewrite this 2 as a fraction? How could I rewrite this 2 as a fraction? Josie, how could I rewrite this 2 as a fraction?
You can rewrite it as 2/1.
Great job. I'm going to do that right now. I'm going to rewrite this as 2/1. Okay. I'm going to show you with a diagram underneath just to prove what we're doing is going to be true. But once I have it written out like this, I can just multiply straight across. Simple multiplication I always know. So I can multiply my numerators together, and then I'm going to multiply my denominators together. But first, I'm going to show this just to show you guys the kind of the same thing that we were doing on Monday with what we're doing now. I'm going to first start with my 2, 6. So right here is 2, 6, 1, 2. And remember, originally they wanted me to show this 2 times, right? So I'm going to show this 2 different times. Here is my first time, and now here's my second time. Thumbs up if I showed 2 6 2 times. Okay, and now I would have just added these together and gotten 4 6. Okay, let's take a look up here now. Oh, and see what happens if I just multiply straight across what I get. So let's look at our numerators first. 2 times 2, show me with your fingers, is what? Nice job. It is 4. And 6 times 1, show me with your fingers, is what? Good job. 6. Did I get the same answer? Okay, so this top method up here is the same exact thing. We're just not showing it with a diagram anymore. We're just multiplying it fraction by fraction. Okay, so let's try this together. I'm going to give you a fraction and a whole number. Okay, your first step should be to change that whole number into a fraction. So let's try 3/10. And we're going to multiply this by 3. Okay. On your papers first, how would I change 3 into a fraction? And thumbs up once you have an answer. Tanush, how would I change 3? Let me unmute you. How would I change 3 into a fraction?
Well, the fraction would be 3 over 1.
Great job. It would be 3 over 1. And now I can just go in and multiply my numerators and my denominators. So please solve. What is 3/10 times 3 over 1? When we multiply our numerators together, what do we get? Raise your hand if you know what 3 times 3 is. Adine, what is 3 times 3?
3 times 3 is 9.
9, great job. And what is 10 times 1? Who has 10 times 1 for me? Anyone have 10 times 1? Bella, what is 10 times 1?
10.
Good job. Okay, so our answer is 9/10. Any questions on this new quicker way? Thumbs up if you like this way better than the diagrams. Okay, if you like the diagrams and you want to keep doing those, that's totally fine. Whichever way works better for your brain. But I do think this method is a little bit quicker because you don't have to draw everything out.